Let's take a look at our next function here on this example as we're continuing analyzing function graphs, talking about relative extrema, finding our turning points, our relative min or maxes, and then, of course, increasing, decreasing intervals, looking at function values, looking at domain and range. So give us some characteristics to our graph. So in this example, it says use your graphing calculator to analyze the graph of the function f of x equal to x to the fourth power minus 3x squared plus 2. Well, we got this degree 4 quartic polynomial, and you can see they've got a quick sketch of the graph already over here. Right. But let's go ahead. We need to get our TI calculator out and go ahead and get a good picture of this function. So go ahead and grab your TI. And I'll pull up my version of the TI-84 up here. And then hit your Y equal button. Right, in your Y equal button, you can go type in x to the fourth power minus 3x squared plus x plus 2. I'll put it in Y1, and I'll graph it in blue color here on my TI-84 app version here that I'm using. With that said, let's go get a graph of it. Now, your window, I like to use a standard window to begin with. Mine says negative 10 to 10. You hit the window button at the top. Negative 10 to 10 on the x-axis. Scale it out 1 unit. And y min, y max, same thing, negative 10 to 10. Scale it out y. Now you can change those manually, or you can hit the zoom button. Hit the zoom button and 6. It'll give you a standard window for it. So there's that graph that we just looked at on our problem. There it is in our TI. Well, if we want to analyze this graph, the first thing you should always do is find your relative extrema. So if you look at this graph, I actually see 3 relative extrema here. There's one, you can see here, I'm moving the dot here. That's a turning point right in there, right? That's where it changes from decrease to increase. So we call a relative minimum. So relative to that part of the graph, we have a min point, right? The points to the left and right of it are greater in value than that one. Now up here you see relative to this part of the graph, we have a maximum point. So again, if you look left and right at that point, values are smaller, right? They're going down in value. So you see again a change from what we call increase to decrease, right, at that turning point, which defines relative max. And then you see this relative min over here where it changes again from decrease to increase, relative min point. So we want to find those points. Now tracing, right now I'm just hitting the arrow button with the trace key. I'm guessing right now with these locations. So what you got to do in your TI, this is important, is you see your second button. So hit your second button, and then above trace it says calc. So hit second trace, and here you'll see your different commands. And if you look at commands 3 and 4, they'll say minimum and maximum in the second trace or calc menu. Well, there's the 2 commands we're going to need to find our relative extrema. So let's go find this minimum point that I was looking at. So I'll hit 3. And then let's go ahead and define 2 bounds. So you'll see probably at the bottom left corner of your TI, it says left bound, ask a question. Mine's sitting at the top. So you see this little cursor here. I need to move to the left side of the min point. So anywhere on this decreasing side of this graph where it would be a left bound, I'm clearly to the left of that point. So to answer that question, you hit the enter button. So just hit enter. And it'll mark it with a little arrow. When your TI, mine's drawing a line through that location, which is around, you see at the bottom left corner, it tells me I'm around negative 1.5 on the x-axis, which is to the left of this min point. And then it asks a new question. After you hit enter, it says right bound. Well, you're going to need to move to the right. So take your cursor and let's slide to the right here. And as you see here, I'm on the right-hand side of this min point. This will be a right bound. So all I got to do is hit the enter button anywhere in here to the right. So I'm at x equal negative 1.09. You can see down at the bottom. That's clearly the right. So I'm going to hit enter. And then you hit enter a third time, it'll lock in on your min point. So you see it says down here at the bottom, min, x coordinate negative 1.30084. So rounding it, maybe we'll go 2 decimal places. Negative 1.30 for the x coordinate. And negative 1.51 would be the min value, right? So for that, That would be our min point. So again, we want to mark that ordered pair. So negative 1.30, negative 1.5. So while we're at it, why don't we go ahead and put that point here on our graph. So let's go back to our graph here. And I'm going to go ahead and show that point on my graph. So right here, we just found this point. This is our relative min point. So we had a x-coordinate, again rounding, negative 1.30, and our y-coordinate was negative 1.51. So there's that min point. So we got two other points, right, to get. We're going to look for this max point and that min point here. So let's go back to our calculator and let's go ahead and find those two. So going back to our TI, all right, let's go back into our second trace button, all right, calc menu, second trace. Now I need to call command 4. It says maximum. So we got a max point next as we're moving left to right along this graph, which is what we always do, observe our graph from left to right. So let's go find left bound. Well, right now my cursor is at negative 0.2 on the x-axis. And that's clearly to the left of that max point. So that would work. So I'm going to hit enter. All right, now I ask for the right bound. So I need to move to the right side before I hit the enter button. So anywhere over here, that's clearly to the right of the max point. I'm at 0.6. It says down here at the bottom of my screen. And I'm going to hit enter. And then it'll give me, if I hit enter a third time, it'll tell you probably guess. So you go ahead and enter a third time, right, to get it. So make sure you go through that guess option. But here I've got 0.17 for the x-coordinate and 2.08, right, for the value. So that's where my max point is located. So let's go ahead and plot that. So as we go back to our grapher, I'm going to go ahead and label that point. So at 0.17, right, on the x-axis. And our y-coordinate was 2.08, so just rounding that to the nearest hundredth. There's that point, that relative maximum point. So we've got 2 of the 3 relative extrema, 2 of the 3 turning points. Let's find the last one, which is this min point. The last turning point we see is a little past 1 on the x-axis, right, just looking at it. So let's go ahead and find that. So back into our second trace menu. 3 is our minimum command. So right now we're clearly to the left. I'm over here at 0.8, right? So that's fine. That's hit enter. And then we'll slide to the right. And then we're on the right side of the min point. Hit enter. And then when it says guess, hit enter a third time. And you see it gives me 1.13 as my location of this second relative min point, right? Our third turning point on this graph. And the value is 0.929.770, so 0.93, right, rounded to the nearest hundredth would be the min value. So let's go ahead and write that down. So we've got our 3 key points on this graph. All right, and let's go ahead and label that. So we got 1.13. So we have a little past 1, you can tell. But now we got the exact location. So rounding 2 decimals. With that said, now we're good to go with analyzing this graph. We've got the key piece of information. So you'll notice the first step should be to find the turning points. So let's look down here at this problem, parts H, I, and J. Ask for these relative min and maxes. So it asks for it in a little different form. It says at x equal what, g of x has a relative, right? So let's just fill in this information that we found. So looking at the first turning point, the relative min. So at x equal negative 1.3, 0, round it nearest hundredth. G of x has a relative min value, or minimum, I'm just going to abbreviate, of negative 1.51. And then over at x equal to 0.0 or 0.17, right, 0.17, we have a relative maximum value, right? And that max value is 2.08. Again, the value is the output, right, the y-coordinate. And then our final turning point at x equal to 1.13, g of x has another relative min value of 0.93. So find those first. And then we'll go back to the rest of the question. So we found those turning points. Looking at domain and range. Let's go back to part A. Domain, of course, where this graph takes place along the x-axis, right? All the real number values of x. Well, in this quartic polynomial, that's true with all polynomials, our domain is always all real numbers. There's no undefined values in a polynomial function like this one. So with linear, quadratic, cubic quartics, we have a domain of all real numbers x. And you can see that this is a continuous function from negative infinity to infinity. No breaks in that graph. So that defines our domain. Now our range is where this graph takes place on the y-axis, right? So range are those y values. Now our range is not all real numbers. So if you want, let's look down here. Our graph begins at that min point on the left-hand side over there at negative 1.3. We had a min value of negative 1.51. Well, that's where our range begins. That's our smallest y value. If I were shading in the y-axis, I'll shade it right here in blue with you, right? We're shading all the way to infinity. Graph goes up forever. So all y values, so as we write our range, put it in interval form, we got an infinite set of values. Again, all values greater than, right, or equal to, so put a bracket here, negative 1.51, right, is our min value, all the way to infinity, all right, would be our range. So there's our range. Now moving on to part C, as we continue to analyze this graph, it says find the set of x values where your function is increasing. So where is this function rising, going up from left to right, right? That's a quick way to look. So I want you to look on this graph. If I'm looking from left to right, it's rising between the first min point and the max point, right? Between negative 1.3 and 0.7 on the x-axis, right here. All right, what's this graph doing? It's going up. As x is increasing, the y values are increasing. So as we write in that interval, the set of x values, so here's our increasing interval, all x values greater than negative 1.30 and less than 0.17. Right. Now that's one of two increasing intervals. We also have an increasing interval to the right of 1.13, right? Look to the right of that last min point. What's the graph doing? We can highlight it here in black. It's going up. So we're going up for all x values greater than 1.13. So we'll write that in interval notation. Just keep in mind, as we write in these intervals, we're not going to ever use a bracket on intervals of increase or decrease, right? It's to the right or left of these turning points is where this behavior takes place, where it increases in value. So it's just sitting there at the ends. So don't include those. Don't put a bracket. That's a common mistake made. Now let's go to D. Let's find the decreasing intervals. So if you're looking at the decreasing intervals, right, where's our graph decreasing? Well, from negative infinity all the way to negative 1.3, right in here. We can shade it in. Our graph's going down. I'll shade it in red. So we're decreasing in the interval of negative infinity to negative 1.30. All x values less than negative 1.30. What's the graph doing? It's going down. Same thing happens as you look between 0.17, between the max point and that final min point. I'll highlight in red. The graph's also going down or decreasing in value. So there's a second decrease in interval. So writing that interval notation, all x values greater than 0.17 and less than 1.13 would be our second decrease in interval. So we've done our increase and decreasing. So that's the behavior of that graph. Let's determine part E, the set of x values where f of x equals 0. So where is this function equal 0? Well, our zeros are location of x-intercepts, right? So we can all see them. There's two of them, right? There's our two zeros. Now here's the thing. I'm guessing one of them looks around negative 1.8 something. You see around negative 2. There's an x-intercept. There's another one over around negative 0.5. So I'm guessing, so this is where we have to go back to our calculator. So it's important. We don't want to guess. We'll know the exact location. So to find our zeros, let's go back to our TI. And you see in your second trace menu, command 2 is a 0 command. So go to calc menu, second trace, and hit 0. And it asks same two questions we got for our min and max points, a left bound and right bound. So I'm going to scroll over, hit my left arrow key on your TI, and move to the left of that first x-intercept point, which is a 0. It's where our function equals 0, right? We're sitting on the x-axis. Well, I'm at negative 1.727. Well, that's to the left. If I'm above the x-axis, I'm on the left side of this x-intercept here. So I'll hit enter, and I'll mark that bound. And then it wants a right bound. Well, you're going to have to move your cursor somewhere to the right. So it'll be below the x-axis, will be a right bound. And I hit enter again. And it gives me our 0. It says negative 1.70211 is a location of that 0. So we just found, right, an x-intercept. We just found a 0 for the function. So let's go ahead and write that down. So negative 1.70 is an x-intercept. So going back to our graph, we can add that information in here. This is negative 1.70. So negative 1.70 on the x-axis. We have that x-intercept. And then there's, so we're going to write that down here. The x values for our function 0 would be x equal negative 1.70. And let's go back and find the other one. There's one more, right? X-intercept. So let's go find it. Second trace, calc menu, command 2, 0. Get our left bound. Now the left bound for this 0 will be below the x-axis. That's the left side. Slide to the right. Anywhere above the x-axis be a right bound. And we got negative 0.71831. So negative 0.72, right? We round it. So let's go back to our grapher. So as we're looking back, this is at negative 0.72 here. All right. So we got two values. So x equal negative 1.70 and x equal to negative 0.72, right? So those are my two zeros. Now where the x values for when the function is less than 0, where is the negative function values on this graph? So I want to look at that. So f of x less than 0. So let's go quickly up here. We can quickly see it. I'm going to circle it. In here, right, my graph is negative, right? It's below the x-axis. We got negative y values in this location. So where is that? Well, it's between those two zeros we just found. So as we write that in interval notation, we got negative function values for all x values greater than negative 1.70 and less than, what, 0.72 or negative 0.72. So there's my x values for where the function is negative. Now let's talk about where it's positive. So looking back at our graph, let's find where it's greater than 0. So looking at our function, of course, in here, right, f of x is greater than 0. Right, all these values, right, are positive. We've got our function values in here. So, right, we got this location. It's positive, right? It's all the way in here. So everything to the right. So again, all of these are positive function values, right? F of x here is greater than 0. So right now in interval notation, so x values, as we put it in interval notation, be negative infinity. So all x values less than negative 1.70, right? Or, right, our second interval, we got all the x values greater than negative 0.72. Right? So all the way the graph goes all the way to infinity. Takes place above the x-axis. So there's my x values where the function is positive. So again, the only place it was negative was between negative 1.7 and negative 0.72. But again, that's a good test question, a good graph to analyze. It's degree 4 quartic polynomial function. All right, so I hope that helps you with these type of problems. We'll take a quick break and continue on our review.